Okay, so welcome guys back again to another video. In this video, we are going to talk about the reflux apparatus. So, what the concept behind this special technique? Okay, first let's look at the problem. Like, why do we use such a technique in the first place? Then let's move on to the concept. Okay, now when it comes to the problem, right? Let's say you have an organic solvent, right? You have an organic sample which you are expecting to do some reaction. So let's say this A is an organic reagent and you need to do a reaction with B. Now this is an organic reaction. This is not spontaneous. You have to apply heat. Okay, now you are using a solvent also. It can be any organic solvent, right? So we are basically talking about the organic reagents, right? Organic reagents, organic solvents, such as. Now the problem is, when it comes to organic compounds, these are normally having very low boiling points, and these are very they can easily convert into the vapor. Now if you applied heat, let's say here you have applied your reagents, now you are doing the reaction and you have applied the heat. Now what will happen is, first thing, your solvent will be evaporated and your samples will be dried out soon. In order to keep the samples well occupied with the solvent, you need to continuously add solvent. So it would be huge amount of solvent you will need in order to do this simple reaction. So that's the main problem. But the other important thing is, these organic reagents are they have low boiling points, right? So when you heat it up, you may destroy your reagents. The reaction may happen, but throughout the process you may destroy your reagents, so the yield will be poor. These are the main two problems you will encounter when it comes to a organic reaction which has to be heated. Now for this problem, when we apply a solution, the scientists have came up with a plan which we are calling it as reflux. Now let's talk about the concept. Here, this is a round bottom flask. Okay, this is a round bottom flask. The round bottom flask is the most suitable apparatus in this case. Now you can use a magnetic stirrer here. It is optional, right? Magnetic stirrer. This is an optional, but I would advise you to use a magnetic stirrer, because with the magnetic stirrer you can evenly distribute the temperature. Otherwise, like, the bubbling can be happen with the reagents. Like, these are organic solvents, so they are having very low boiling point. So the bubbling will happen, then the solvent would be kind of mess. So by using such a magnetic stirrer, you can evenly distribute the heat. Now then you can use a hot plate or normal heating pad, something to heat it up. Now the important things is, we have used this kind of instrument. This is similar to the instrument which we are using in simple distillation, if you remember, which we are talking about in our basic chemistry, right? So this is the same instrument which we are using in the simple distillation. Now you can input your water, cold water, right? This should be a room temp cold water, not mean like it doesn't have to be a 0 Celsius, no, just like 25 Celsius, the room temperature water. And then let me draw it correctly. Okay, now here from this place you are going to input the water in, and here you are going to take the water out. Now what happens is, you can see there is a line here, there's a tube here. This tube is separated from your water, so water is going around this tube. The water is in these places. The water cannot go inside this tube, and water cannot go inside to our flask. These are sealed off. Now when we are heating the mixture, right, the reaction would take place inside this compartment, and you will know eventually our solvents may vapored out, right? So the solvent vapors will go through this tube. Let me take another color. So let me take another color to explain it. Okay, the solvents may go through this tube, and in this particular positions you can see there are cold water outside. So this vapor can be converted back again into the liquid, and it will pour down to our solvent again. So this will happen at like a cyclic. So your solvent won't be wasted, because your solvent won't be go outside, because it will be cooled down to turn back into a liquid. So it will come back into a solvent. This cooled solvent will come back into a solvent, and then it will heat it up again. Then it will go to the vapor, and it will cool down again, come back to the solvent. Likewise, this will happen like a cycle. So your first problem, our reaction solvent is not going to be waste. It will protected within this apparatus. And the second thing is, okay, you can see with this cooling solvent coming back into our solvent, and we can heat our sample for constant temperature. Like if we want to heat it up for the Celsius 100, let's say 100 Celsius, so the solvent or this mixture will keep it at that specific temperature because of this process. Okay, it will not go higher than this temperature. Our reagents won't be destroyed using this, because it won't get dry, right? You get it? So this is the basic idea of the reflux. The most of the people confused with this technique, this reflux techniques, with the simple condensation. Condensation and reflux are both are different things. With the condensation, you are doing a separation mechanism. Okay, this is not a separation mechanism. This is just a reaction under a specific conditions. We are not doing any separations. In condensation, like we have talked about the condensation in a separate video. Like in a condensation, what happens is, sorry, not condensation. The simple, in a distillation, what happens is we are separating out our sample. Okay, maybe let's take an example. Let's take simple distillation. If you remember, in simple distillation, what will happen is we are going to separate our solvent or our solution from an insoluble or like tiny particles, tiny cations, salts, likewise. Okay, so simple distillation is a process which we are using to separate things, separate components. This is not a separation. This is just a giving the conditions, giving the suitable condition for our reaction mixture in order to achieve a higher yield. So I hope it's fine with you. If you have any problem with the reflux, feel free to comment below. We will talk about. I will help you as I can.